architect, and here I brought today here class 9 maths number system chapter number 1. So I hope you will enjoy. In this chapter we have to know the different types of the numbers. So first of all, what we can discuss is the number system in this chapter is the natural numbers. As we know, those number which starts from 1 to infinity. You know, infinity is nothing that is the uncountables. Are called natural number, and you know it is denoted by that means the natural number is denoted by capital N. So that is here N natural number is start from 1, 2, 3, up to infinity. Infinity here is denoted by the alpha. Actually it is the Greek letter, and this determines that is uncountables. Okay, so the most important points you have to know is that the smallest natural number, just I represent it by n, okay, is 1, and the largest natural number cannot find out. Cannot find out. So these points we have to know. So this is all about the natural number, and its relationships with the others number, it will comes in the next topic. Okay, and the next here it comes to the whole number. So whole number, those numbers which starts from 0 to, or you say up to infinity. Okay, zeros up to infinity are called whole number. Okay, 0 से शुरू कर that is uncountables numbers को whole number जाना जाता है. It is denoted by W, capital W. Okay, so therefore W is equal to start from 0, 1, 2, up to infinity, that is uncountable. So the important points here we have to know is that the smallest whole number is 0, and the largest whole number is that W is called uncountable, or you say infinity, or cannot find out, we can say. Cannot find out. We can find out for a particular number, say from the 0 to hundreds. In this case, the smallest whole number is 0 and the largest whole number is hundreds, if the number is given in the definite form. Yeah. Okay, now we can discuss the relationship between the natural number and whole numbers. N and W, that is a natural number and a whole number. Okay, as we know, the whole number is start from 0, 1, 2, 3, 4, dot, 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 up to infinity. And we know that natural numbers start from 1, 2, 3, dot, 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 up to infinity. That means that whole number are natural number, but natural number are not whole number. Why? Because here natural numbers start from 1, whole numbers start from 0. And including all these things, they are natural numbers, but 0 is not included. So this is the whole number. Whole number, total is whole number, but natural numbers are this. You see, natural numbers are here and a whole number. That means that all the natural numbers are not whole number, but whole numbers are a natural number, because inside the whole number, all the natural numbers are included. This is the relationship between the natural number and the whole number. Okay, now we will discuss about integers. The set of negative numbers with whole number are called integers. And also we must know that integers can be shown in the number line. Okay, so here integers can be shown in the number line. So this I will show you here in the next topic. So like the successive magnifications and all. Okay. So first of all we have to know the integers. Here it says the set of negative numbers with whole number are called integers. So say here 0. On the right side here 1, 2, 3, 4, dot, 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 up to infinity is there. And here in the left side of the 0, here it comes to number -1, -2, -3, -4, dot, 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 up to negative infinity. That is the uncountable in the left side also, on the right side also. So this -1 up to the infinity, they are known as the negative number. Negative numbers. And right from 0 up to the infinity are called as the whole number. Yes, we can denote it by the W. So it is the minus, and also we can represent it, this negative number. So this one. And the important point that we have to keep in mind is that the largest negative number is -1, and the smallest negative number is infinity, or yes, they cannot find out, or you say uncountable. Okay, so this we have to know, and for the whole number, as we know, 0 is the smallest and the largest cannot find out, like that. But we have to keep in mind that in the negative number, smaller the smaller the number, that if we compare -1 and -4, the number is small as we compare 1 and 4, 1 is small. But in terms of the value, in negative number, in terms of value, -1 is the larger. That means the -1 is greater than -4. Okay, so we have to keep in mind in this minus, larger the number, smaller will be its value than the smaller number. So -2 and -1, -2 is small, -1 is larger. -3 and -4, -3 will be larger than the -4 in terms of the value. So we have to keep in mind these ones. Okay, now we have the another numbers, that is the rational numbers. Okay, so rational number is defined as any number which is or which can be expressed, also you can write, which can be expressed in the form of P by Q, or sometimes you will get A by B in some books, where P and Q are integers and Q, if we write this is equal to, but if we cut a line as a transversal, then it is the Q is not equal to 0. I'll call rational number. Okay. And here we have to know the examples here. Rational numbers. Example is 1 by 2, 4 by 2, 3 by 6, etc. Okay, so these points we have to know. These are the rational number. Here we have to keep in mind, excuse me, the value of pi. The pi value is equal to 22 by 7, as we know. This is in the form of the P by Q, isn't it? But pi is not a rational number. Okay, the value of pi is 22 by 7, that is, which is in the form of the P by Q, but pi is not a rational number. Why? Can you say why? Okay, so this we will discuss here now. Okay, here, why pi is equal to 22 by 7 is not a rational number. So for this one, we have to do the divisions here. We'll divide this 22 by 7. Okay, 7 to the 21 comes to 1.071 7 comes to 3 point already 0 for 7 the 28, and here comes to 2 0. Okay, 7 to the 14, it comes to 6 and 0 8. 7 is 56. Now comes to 4. 0 again. 7 5 is 35. And here comes to 5. 0. How much we can go? 7 7 is 49. And here remainder is 1 again. You see here, but here also same thing. If we continue, then already put point there, then we can comes down 10. And see here these two numbers. Here also coming 1 0 and here also 1 0. That means that if we keep on division, then all this value will keep on repeat. So from here we can conclude that here the value of the pi is equal to 22 by 7. Here it comes to 3.14287. Again here if we write, if we do the divisions method here again 142,857. That is it cannot be finished. It keep on continue throughout whole our life also it will not finish. So here we can write this number as 3.142,857 as bar. It is not that these numbers are repeated. Okay, so such kind of the numbers are known as the non-terminating. This is called as the non-terminating. Okay, non-terminating. Yeah, this is decimal, you can say, decimal expansion. Non-terminating decimal expansions. Okay, and we have to note that such kind of non-terminating decimal expansions are irrational. Another number will come as irrational number, or we can say are not rational according to our why pi is not a rational, no? Because we get a non-terminating decimal expansions. Okay, that's why it is not rational number. Okay, so not only the value of the pi here, there are different numbers are there. Say for example here 1 by 7. Even though it is in the p by q, in the form of p by q, it is not rational. Because if we keep on dividing 1 by 7, then we will get such kind of non-terminating decimal expansions. And like 11 by 7, etc. Okay, so many other numbers are also there. So such numbers are not rational and they will come under the category of the irrational number. So now here we will discuss about the irrational number. Now here comes to the irrational number. Any number which is not in the form of, or which cannot be expressed also, we can say, okay, no problem. In different definitions we can get any number which is not in the form of p by q, where p and q are rational and q is not equal to, in this form the writing also okay, equal to 0. Okay, so it is called irrational number. So I am not giving the conclusion here. Any number which is not in the form of p by q are called irrational numbers. Like shortly also we can write, no problem. So examples of the irrational numbers, they are coming under the roots, like say root over 2, like root over 3, like root over 5, like 2 plus root over 3. Yeah, this also we can include under the irrational number. Okay, so such kind of the numbers are called as the irrational number. But important points to be noted is that Why? This root over 1, root over 4, root over 9, etc. Many other numbers are there. Is it irrational number? Okay, the answer will be the answer of this root over 1, root over 4, root over 19, root over 25. They are irrational or not? The answer will be no. And they are rational. Why? Because root over 1, here we can take any square or any values, any powers of the 1, it will be the 1, right? So we can take here 1 square and it cancel out and it comes to 1, which is rational. And also root over 4. Yes, we know 4 can be divisible to root over 4, right? Then here it comes to root over 2 into 2, and here 2 square. Squares could cancel and 2. Here we got right, which is rational. Okay, which is resonant. And here again you may get doubt about this one. Why 2 is resonant? You may be confused that 2 is not in the form of p by q. Of course, this is in the form of p by q because any numbers, any natural number, okay, are in the form of p by q. That is 1. We can write down. So all the natural number, or not only the natural number, all the whole numbers are a rational number. Okay, so which is in the form of p by q. We have to keep in mind. But all the irrational number, okay, and rational numbers, they will be different. Okay, so you may think that when you root over values it will be irrational, but it's not, because the root over 4 that comes to 2 into 2, 2 is square cancel, it comes 2, which is rational. So we get this is a rational number, not a irrational number. Okay, now we have the number lines and the successive magnifications. Okay, as we know right from the lower classes, the number lines. Here, this is 0 as I have shown there in the integers, and the right side is the 1, 2, 3, 4. Here also -1, -2, -3, -4, -5, etc. That is the many uncountables are there. And here what we are going to discuss today is how many numbers are, or they say how many rational numbers are there in between any two numbers. This is the question. How many? And answer is infinite. There are infinite numbers are there in between any two numbers. Say for example 1 and 2. Between the 1 and 2, how many numbers are there? Can you see any number here? No. You will say no numbers, right? But I will say there are infinite numbers are there in between any two numbers. But how? How? That's only we have to discuss. We have to find out how. You will come to know after this. Okay, so let's. Okay, to understand is more better. Here we will use a ruler, or you say scale, and here you have see here this is 0, 1, and this is 2, 3, 4, 5, right? And what do you see here between the 1 and 2? How many small divisions are there? 1, 2, 3, 4, 5. This the longer one is up to 5, 6, 7, 8, 9, and 10, right? So here between the 1 and the 2, here there are some other numbers. So let us find out how and how much. Okay, and this will be done with the help of the successive magnifications. Okay, So here we will go for the successive magnifications here. Okay, so you take here it is 1 and this is 2. Okay, it is not scaled properly. Okay, just I'm looking here. Okay, say up to here is, yeah. Okay, so how much will be this one? That is the questions, right? So here is 2 and the next number going to come is 1.1. Next is 1.2, 1.3, 1.4, 1.5, 1.6, 1.7, 1.8, 1.9, and then here it comes to 2. Okay, so there are how many? 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers are there, right? So let's you pick up any numbers in between. Just say these two. So first one is 1 and 2 in between these two. And now I will pick up 1.4 and 1.5 in between these. How many numbers? Let's see here. This is 1.4 and this is 1.5. Okay, just I take it the middle only. 4, 5, 6, 7, 8, 9. Right. And here will come how much? 1.41. It doesn't come to 1.44 like that. Okay, 1.41, 1.42, 1.43, 1.44, 1.45, 1.46, 1.47, 1.48 and 1.49. After 9 it comes to 1.5 as you know. Okay, so this is the successive. This is called the successive magnifications. So what I have written here. Okay, so let's take one more. Say 1. As you wish only. Okay, anyone we can take anywhere. Okay, so here I take 1.44 and this is the 1.43. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so what number we can get? Here will come 1.431. Here will come 1.432. Here will come 1.433. Okay, I'll write up down. 1.434. Here will come 1.435. Here will come 1.436. Will come 1.437. 1.438. And here will come 1.439. After then 39, then comes to 4. 1.44. So this is also a successive magnifications. Okay, so this is how we can write different numbers. If we keep on continue, it will not finish. So from here we can prove that here there are infinite numbers. Infinite numbers are there in between any two numbers. That is, uncountable numbers are there in between any two numbers. So this is all the theoretical parts of this chapter, and we can proceed to the exercise. Okay.